Good day, students! Welcome to Earth and Life Science. Our milk for today's videos are: describe where the Earth's internal heat comes from, describe how magma is formed. Today's milk is included in what we call the endogenic process. What's the endogenic process? This is the process that occurs beneath the surface of the Earth. It is also associated with energy originating in the interior of the solid Earth. The two types of endogenic processes that we will cover today are interior heat, magmatism. Interior heat, or the heat in the interior of the Earth. We have two categories of the internal heat sources of the Earth. First, we have primordial heat. Second, we have radioactive heat. Primordial heat is the heat generated during Earth's formation. Heat from accretion and bombardment of the Earth during the early stages of formation as failed planets and smaller asteroids slam into larger worlds. The energy brought by the impact of the moving asteroids transform into the interior heat of the Earth. You can imagine smacking your arm multiple times. You can notice an increase in temperature. The next type of internal heat source is what we call radioactive heat. Heat is generated by long-term radioactive decay. Its main sources are the four long-lived isotopes, namely potassium-40, thorium-232, uranium-235, and uranium-238. These isotopes make a continuing heat source over geologic time. Magmatism. It is also known as magma activity. Magma is a hot fluid material beneath or within the Earth's crust. Magma forms in three environments. First, we have subduction zones. And as you can see from the diagram, the oceanic crust subducts or goes under the continental crust. As the oceanic crust dives deeper, this results in the melting of the crust that forms more magma. Magma generated at subduction zones are andesitic. It is richer in silica than basalt and therefore more viscous. Eruptions is explosive and produces ash. Conditions for magma formation at subduction zones. First is increased temperature. Friction caused by the movement of plates adds more heat to the melting. Second, we have addition of water to the asthenosphere. As the soaked oceanic crust dives into the mantle, the seawater boils to generate steam. Steam and hot water rises and melts portion of the asthenosphere, thus adding to the formation of magma. Third, pressure relief melting. As the rock rises through the mantle, the surrounding pressure decreases and eventually the conducting rock melts as a result. The next environment is the mid-oceanic ridge. Magma is released at a diverging plate. As you can see at the middle, the hot magma oozes up to fill the gap. Magma generated at the mid-oceanic ridge is basaltic. Third, we have the mantle plump. These are columns of rising mantle material that begins to melt as it rises to lower pressure or shallower depths. If magma breaks through the lithosphere, it forms into a volcano. Sometimes, the magma does not reach the surface. Magma can cool at various depths, producing magma bodies called intrusive igneous rocks. If magma manages to escape to the surface, the magma that solidifies at the surface is called extrusive igneous rocks. I hope you learned something. See you in the next video. Goodbye!